Hey, you're still muted. Yeah.
Yes, yeah, I always forget something with these online events. It's just, but anyway, everybody, welcome to tonight's event. It's really great to have everybody here and to this meetup tonight. That I'm
Hey,
personally.
you're still muted. Yeah.
Yes, yeah, I always forget something with these online events. It's just, but anyway, and I'm really curious about tonight's event. Now, all the technicalities should be corrected, and we can start. Move over JDBC. R2DBC is here. I'm not going to into the content of this because we have an amazing speaker tonight, Frank. He's going to tell us all about R2DBC. But what I want to say is a couple of things. First, tonight's reactive meetup is the first one when we try to bring a lot of different reactive communities together from all over the world. So in fact, this meetup was announced on a lot of different groups. Reactive Amsterdam, the meetup that I run, but also Reactive Systems Programming, a meetup in India, Amsterdam Kotlin, Amsterdam Scala, Reactive Technology Belgium, Reactive Vienna, and Adesso Software Development. So I am really quite excited about this first experiment in bringing together a lot of communities from all over the place. You know, being remote, sure, there is the time zone difference. That's always going to be an issue. But, you know, we're making steps towards sort of being a real global community. And let's see how that goes. Another thing that I want to mention before we start is there is a conference called Scale by the Bay. It's actually starting tomorrow and the day after. It's based out of San Francisco in the United States. So there is a, it depends. Again, time zones for us in Europe is -9 hours. And so it basically goes late into the night. But the schedule is really incredible. There's a lot of incredible speakers there. And I managed to snitch a last-minute discount. The one you see at the bottom of the slide gives us 20% discount. And it's already not very expensive. It's about $100. So 20% discount is anyway nice. And I would really recommend to give a look at the website and at their schedule. I think it's really a super cool conference about scalability, data, DevOps, artificial intelligence, and all the things that we usually deal with in this kind of community. And then finally, our next event is already scheduled, and it's going to be about Kotlin. So lots of core routines, asynchronous stuff happening, reactive streams. I'm pretty excited about that too. It's in about 2 weeks or so. So go check it out. We'll try to announce this one in many different places as well. And this is it for me. I would like next to introduce our fantastic partner and enabler for tonight, Adesso Nederland. And David, my friend, is going to say something about it. So please take it.
All right. Thank you, Fabio. Okay. So, hey, everybody. I'm David. I've been a developer since 2005, and I'm currently working at Adesso Netherlands here in Amsterdam, which is one of the most recent branches of the Adesso group. Adesso was founded back in 1997 and has since grown out to be an international organization with over 4,200 employees across 36 offices in 8 countries around Europe. And with the mantra of business, people, technology, as a company, we really value our people and absolutely love technology. There's room for experimentation, and there's a lot of attention going to personal growth and continuous learning. But you don't have to take my word for it. The awards our German colleagues have collected over the last couple of years speak for itself. And here in the Netherlands, we aim to do at least as good. So if you're a developer looking for a new challenge, make sure to shoot us an email, and we can take it from there. All right, so that's it for the commercial break. All I want to add to that before we can start is that you can drop your comments, questions in the comments, or if you don't have an account on YouTube, you can't comment here, but we set up a comment section on sli.do/R2DBC, where you can also leave the questions, and then we'll pick them up after the talk. With all that behind us, I'd like to leave the word to Frank, our speaker for the night. And then we go, oops. All right, and I'll remove us. All right, take it away, Frank.
Okay.
And thank you.
Hi, everybody. I hope you can all hear me all right. I'm Frank. I have been a developer architect for ages. I don't care to think about how quickly the time progresses anymore. Today I'll be talking about the R2DBC and how it relates to JDBC. It won't be an in-depth tutorial in the sense that that I'll go in all the technicalities, but I will more go into the concepts to know whether it works out for you, whether it makes sense to go there, or just things to think about. So let's get started. But before that, I have a little more commercial break for my current employer, Quinn.md, which is a Dutch healthcare startup. We just went live 2 weeks ago. If you want to be my colleague, there are lots of positions open, front-end, back-end, infrastructure, architect. So if you are interested, drop me a line or swing by the website, and that would make my employer really happy and me as well. So let's get started. So if we are going to say we have something new, something like R2DBC, that kind of implies there is something wrong with what we had before. And the question rises then, what's wrong with JDBC? There's a lot wrong with JDBC. It's an old API from over 20 years old. So in that case, there is always a lot wrong. But it's usually not really an issue because few developers ever touch JDBC nowadays. There are so many layers and frameworks that do that for you. So even the problems we usually have with JDBC, we don't really notice. But there's one, and that's that JDBC is blocking. Blocking is an issue, and that's something I will dig into. So let's show some source code of some really vintage style code. I guess many of you haven't written much of this, but if you're old like me, then you know. Young ones might not even have born by the time this was popular. So what we do here, it's a request to query, get a list of film titles from a fictional database. So if I go through the lines, I get a connection from a driver manager pointing to a local Postgres database with the credentials. I create a statement, select from film. I execute the statement, I get the result set, and then I loop over the result set by calling next until I'm done, and then I'm done. So that is basically what happens, and that looks not exactly pretty, but it's okay. So what's wrong with this? Well, one of the things is what we call a leaky abstraction. It's an abstraction that is kind of okay, that works for most of the time, but not always. And usually at the worst moment, those abstractions kind of fall through. So, and abstractions is something in software engineering that we do all the time. Like if we wouldn't have abstractions, we would be flipping transistors all the time. It's not something what we want. But right here, there are a lot of leaky abstractions by the code I just went through, because the things I said weren't really true, in the sense that you can't really get a connection to something, because what you can do is you can send some bytes over a line to a database you suspect is there, and then you get a reply, and if you are happy with the result, then you could say I have a connection, but it's not something you do. The same goes with executing a query. You send a message, I would like this query, and hopefully data comes back. But it's not something you do. You send something and then you wait. The same goes with a result set. The next call, that very well might make another round trip to the database to indicate, to request more data, because it doesn't mean that the entire data set is already here. Finally, I write with the response writer, I write it to the output. Also, it's not something you do as such. You can offer some data to the operating system and say, please send this over the TCP connection, but you can't do it. You have to wait then until the operating system says, yeah, okay, done. And then you continue. So there is a lot of, waiting involved in all this. So another thing, because JDBC is blocking, you can't wrap blocking code and make it non-blocking. Like a lot of the issues we have with JDBC, like the weird syntax for the API, it feels really old, but you can wrap that into something else, and that's nicer to work with. But for blocking, you can't. If something is blocking, it is blocking whatever you wrap around it. Like, in a sense, if you have a thread that enters a method, then there is no way to get it out of there, right? You can't really do that. So in that sense, this is something that needs to be fixed on a fundamental level. Another fair question to ask is this a problem? Is it a problem that it is blocking? And maybe, but also maybe not. It is not slow. We have been building applications like this for decades now, so we shouldn't pretend that this is impossible to work with. But the question is more, can you afford it? It is really nice if you can afford it, but if you can't, in some cases you might not. And the analogy I'd like to go with this is like, suppose I'm really rich and I have a car and I have a driver. From my perspective, it is a really nice situation to be in. I can go wherever I want, and when I'm at my destination, I just get out and I do my thing. And when I get out again, then my driver James is waiting, and I drive me somewhere else. So, from my point of view, having a car and a driver is perfect. However, for the driver, it might be pretty boring to sit waiting around, and as a system, it's problematic as well, because there are a lot of cars and drivers sitting around doing nothing and being wasted. So how we would change that within this analogy is kind of obvious, to use some kind of public transport or an Uber or a self-driving car, something like that, something that can be useful while we do the things we want to do. But that would involve some changes from our side. We need to make sure that, for example, we can't leave stuff in our car. Normally, if you have your own car, you can just leave stuff there. Next time you get in, still there, in most cities. But in general, this change does require a change in our behavior. So if we take this back to our piece of code, so let's assume we have a certain number of requests per second. So we have 1,000 requests, 8 milliseconds. I'm just saying numbers. It doesn't really matter absolutely. We have database queries, and we have the whole service takes 10 milliseconds, and the database query takes 8. Just some numbers. So that would imply that as we can do 100 requests per second for a single thread, we need about 10 threads to do the 1,000. And that is, that's okay. So, but what if the database gets a little bit slower, right? So maybe there is some indexing going on, or somebody else does a heavy query, or who knows. There is something, the database gets slower, and instead of 8, it does now 16 milliseconds for a database query. So that means that our service time would go up to 18 milliseconds, and that means that we now are using 18 threads, even though we're doing the exact same amount of work. And 18 threads is not a problem at all for a modern machine. But when you get to hundreds of threads, thousands, then even the beefiest machine goes down. So it is a weird situation that we have more and more threads because things are slow. It kind of sounds like you say, oh, it takes a lot of time to get around, so we need more cars. While that is also exactly the problem, right? So it's kind of circular. So also is a problem. We don't really control the amount of requests we get, and we can't really control the response time of the database from our application's point of view. So that means that we don't really control the amount of threads we need. And that's a risk, right? Because if, as I said, if the database becomes slow or we become overloaded because there are more than 1,000 requests per second, then the amount of threads goes through the roof, and that can take your system down. It can break everything because once you get too many threads, your memory consumption gets really high. Your garbage collector goes berserk because it can't really keep up with all the memory. Maybe there's even some swapping involved. And then the whole system starts to slow down, so that even makes it worse. And then maybe the original thing that caused the database to go slow is no longer an issue even. It might have been a really short interruption, but now because all those threads are falling over each other, your system goes down and it's not even clear why. So how can we fix that? Well, we can go cloud native, which is very popular now. And I guess that is really very popular if you have something like a Kubernetes cluster. You can tune it to say, like, if the load is very high or memory consumption is high, we need more machines. And I guess Google and Amazon and the others get really happy for that. And then we say, oh yeah, look at that machine. It's really busy. There's so much memory, so much CPU. It's a really busy machine, so we need more. It might not actually be true that it needs more, but it really looks like it. It's really difficult to see the difference between a machine that's actually busy and that's a machine that has just so much threading going on that it just seems very busy. So we can mitigate this a little bit. For example, what every sane developer / framework does is limit the number of threads that's incoming. So usually something like 100 threads or something. That will keep your system alive generally. But then that doesn't mean that you start to queue requests and that you're going to drop requests. And in this particular case, it is pretty straightforward because they all do the same thing. But if you are in a situation that some calls need a database and some don't, we have to start at the gate, because the moment we accept the connection, then the thread is bound to that for the duration of it. So we can't choose, like, maybe some of the results are cached and then we don't need the database and then we can return it. But we can't do that because we will queue all the events and we will drop some of the cached ones as well if that's the if we need to drop requests. So it is not really addressing the issue. It is kind of a game of whack-a-mole. We're trying to mitigate the damage of being blocking. But actually what we would really like is non-blocking code that does not have this problem fundamentally. So first of all, let's look back at the blocking code. In some, and I would say even many situations, blocking code is just fine. If you have enough threads to do the load you want to do, and all the different parts of your service are nearby each other with low latency, then blocking code tends to be completely fine. But at scale, you can have performance that suffers a little bit, that you slow down, and stability as well if your load gets too high. And also not just that it will go down or something, because that would be pretty straightforward to deal with, but it will behave in a really unpredictable way, and it's really hard to troubleshoot. So there have been non-blocking APIs. They have been around for a while. I looked up a few, and yeah, there are many over a decade old, and they are not new, not by any stretch of the imagination. But up until the last few years, you rarely see them in the wild, and that is because two things. I think there's a lack of standardization, and it is just really hard to work with. And let me give a little bit of an example of that. So this is again the same code I had before, but now as a sort of pseudocode to really boil it down. And if I have a blocking API, I can see it as an iterator. I call a method with an iterator of rows, and I call that, and then I can loop around it, and I just, for example, I write it through a socket or something. It doesn't really matter what that is. That's straightforward. That's what we're used to. But if we would do something non-blocking, then that would look something like this. We have, again, a query, but now we provide a callback. So a method that gets called for every row we return. And this method itself will return straight away. So that returning straight away is important because that's the essence of non-blocking. And then we use the callback to get our data back. But that is a problem in the sense that if you have like in this situation, it is a trivial situation, it's really simple, just one thing, then it's okay. But if you have many asynchronous method, you get the so-called pyramid of doom. Your code slides more and more to the right. You have no idea at some point in which context you are, because there are that nesting that really messes with your brain. So in that sense, it is really unpopular to work with, and over the years, generally the community has said, no, we're not going to do callbacks. That's not pleasant. So we need to do something else, and for that we have a thing like a completable future. That's something that is also in the standard JDK. And that's a mechanism where you can return something that will contain a value. And because you get a notification basically when the thing inside the future arrives, you can chain them together. And in this case, I use the then accept. Yes, Reactive Framework solved that. That's a question, and I'll get to that. So you can chain them together. What this does have a downside, though, in the sense that a completable future has one answer, just one. So you either have the answer or not the answer. And in this case, if you have a big select statement, might be a million rows. And before, in the blocking one, we could stream it out. We don't need the entire result set in memory. So, but right now in this one, we do, and that's quite an expensive thing to do. And that's one of the big discussions that was with Oracle and ADBA. I'll get back to that later. But it turns out that for data-intensive situations, that is too much. You can't expect the data set to be in memory. So another thing that we didn't address is that if you write if your write is also non-blocking, because before we had we left the write as is, but if it's also non-blocking, we have a bit of a problem if that write is slower than the database, right? Because the database just starts pumping out all the rows and just sending them to write non-blocking. And that will just return immediately because it's non-blocking. But what it actually needs is the writer needs a way to indicate back to the database that it's too fast and that you need to control the speed. And right now we don't have such a way, because now we just hope that the write can keep up, and if not, it's a problem. So we could do something like give the write non-blocking on complete runnable, so that we get a signal back when it's done, and then we have to somehow transport that data back to the database driver. But this is not really a level you want to be operating at when you're just writing your application. You want to automate this. And this particular situation is called back pressure. So we need to be able to balance the database, in this case, at one end, then the application server, and then the client. And the data should not be arriving quicker from the database than it can write to the client, or the other way, doesn't really matter. But we need to be able to balance that. For that, there is a framework, the Reactive frameworks. It's originally by Erik Meyer in 2013, I think. The original one was for .NET, and then there was the original RX Java. And in 2014, I think there was a standard, and that standard was called Reactive Streams, and that does this basically exactly this. The standard later got included in JDK itself in the from Java 9 on, but it's actually pretty simple specification. It's only 4 classes. 4 interfaces. The first interface, the processor, is not that interesting. That's just a combination of a publisher and a subscriber. And the publisher has one method, subscribe, and there a subscriber basically offers itself to a publisher to say, I want to receive your publication. The subscriber is a little bit more interesting because that will have different methods to receive the data. So the most important one is the on next, because then you actually receive something, and when everything is done you get an on complete to indicate that this stream is done. Might be never, might be internal, but that's how you receive. And when something goes wrong you get an on error. And also the on error I'm going to skip over because that's going to be out of scope a little bit. And on subscribe you receive a subscription object, and the subscription one is the most interesting, I think, because there you have a cancel method. A cancel method, and in blocking code, canceling is next to impossible. Once a method is inside the thread is inside the method, there's really no way to stop it. But for reactive applications, you can, and that's actually quite powerful. Second one is request, and that is telling the publisher that you can take more data. So if you say request 1, then the publisher will, if it has something, at least publish 1. And if you have, so you basically can use that to balance the speed. And if you don't send anything, it will just stop. So this is the specification, and there are implementations. RX Java 2, that's iteration on the first one, implements this. Spring Reactor is similar. Akka Streams is one, and Vertex, I think, also implements the reactive streams. And even though they're quite different and they have different operators, they are pretty easy to integrate because they have like they're philosophically compatible. All the operators can be different, but you always have a way to subscribe to some kind of publisher or be able to publish to some kind of subscriber. Another part of this, of the lack of standardization, is that Oracle has been promising some kind of standard alternative to JDBC, because there were those drivers, as I mentioned, but yeah, there was never a standard like JDBC. And if you use JDBC, you might not like it, but if you have one JDBC driver, it's pretty interchangeable with the next, and we didn't have anything like that for reactive drivers. So yeah, so that's the lack of standardization part. Enter R2DBC, and I don't know the exact origin story, but I got the impression that basically the Spring people, so that's Pivotal back then, now VMware, got tired of waiting for Oracle to have some kind of standard to work with, so they started their own standard, and based on the reactive streams, and right now it's under the Reactive Foundation, I think. So it is that's part of the Linux Foundation, if I'm not mistaken. So it is really a standard, but not officially blessed by Oracle. But I don't think people mind too much. Yeah, it is pretty new. It's from 2018, so it is still in the 0.8 timeline. So it is not really very rugged yet, but it's getting there. So R2DBC, let's look at a little example. You can actually use it with servlets. That is a sort of archaeological hobby of mine, but I'm not really expecting anybody to do it. But the R2DBC part is just standard. So we create a configuration object with all the predicted, all the usual suspects like the database, the host, the password, user, whatever. And then we can just create a connection, and that's not really creating a connection. It creates in this case a mono. That's the Spring version of single, I think. That's the different names between RxJava and Reactor, and that's something that will contain a connection once it's there, but not straight away. And then this flat map many will just be executed when the connection arrives. It will create a statement and execute it. That will eventually turn into a result set stream, and that will be flat mapped through another function, the next line. And basically what we're going to do, we get the title from every row and we stream it into a string. And then the last few are just getting the bytes and making the byte buffer and sending it out of the servlet. So this is usually not really necessary, but in this case it is. So the idea is that we just subscribe to the results of that query, and the result starts flowing, and we just stand there and look at it. We don't need to do anything. It's very declarative, which is kind of nice. And we are not thinking about that we need to be quick enough in shoveling the data from the database to the client. So let me do a little bit of a demo. The demo will be in Kotlin. I hope you don't mind. So by far, wait, I need to mirror my display because otherwise I get seasick. Arrangement, mirror. Ooh, that's crowded. Okay, the easiest way to use R2DBC is not surprisingly inside Spring, because it's a Spring product. I'll get back a little bit about using it without Spring, but I have a little bit of a demo here. I'll have a link to the GitHub repository later if you want to play with it. It's the most basic of applications. I have an application, a controller, and a repository. The controller has a few endpoints. Let's start with the last one, the filmed flux. Basically what it returns is a publisher of a mutable map in this case. So it just calls the repository, and what that does is just this. What happened? So the database client of Spring does some of the heavy lifting, and there's also the usual Spring configuration to do that, and the connection pooling and everything. That's a little bit more work if you're going to do it all manually. So right here we have the films as flux. So we have the query, and we just do fetch, and we do all, and we get a flux out of that. The flux is also a publisher, so in the controller, as we could see, we can just return that. And then from then on, Spring does the rest of it. So when I call this, Spring will basically do that whole balancing by that the data doesn't get faster out of the database than the client can receive it. So let's show that. I can run it. Oh, it was already running. Shouldn't have left it running, maybe. Demo gods. Let's maybe we do it from command line. Wrong directory, sorry. Let's just see if it wants to talk to us. We can do a curl command. Let's do curl localhost 8080 films flux, and it gives the result. It's nicer if you pipe it through JQ, because then you get some formatting. But it is not spectacular, of course, but it is indicating how that you can get to a pretty clean style of coding here. You can, of course, do pass parameters into the queries. So, for example, if I want to query the actors of a certain film, I can have one here where I just add the ID. Same thing, I just have the query, I bind the parameter, and then for the rest it's the same. Only here I only return the IDs, so it's a flux or a flow of short. The last one I want to show you is a bit more complicated one. Is one where I assemble all the films and all the actors. So I have first I query all the films, and then for every film I query all the actors that is from that film, and for every actor I just query the name. Now, I'm very well aware that it is a ridiculous thing to do for a relational database, but just to show how you assemble different operations. So let me see what was the name? Films with actors, okay. So we go here, and then we do films with actors, why not? And then you see that it starts streaming, right? So it is not like at once, it is streaming. And it's actually doing a lot of queries. It's doing like 6,000 or 7,000 queries in total. So it's actually performing quite nicely for that. But again, this is not something you would do usually with your database. So that was the demo part. Let me get back to the slides. Here we go. So I need to say, like, I've played around with it quite a bit. It is still quite young. Even while writing this demo, I found some weird things. Something with that the shorts and the integers got mixed up. I only looked at the Postgres driver, but there is there are still some rough edges here and there, and there are also some data types with the more exotic ones that are not supported for every database. So you have to be a little bit careful there. I didn't do any serious benchmarking here, but one thing to notice though is that in my if you look on the internet, you'll find a lot of benchmarks, and generally what they tend to do is just take a small example, and you have maybe 50 threads or something, and you query a lot of database, a lot of simple queries to a local database, and that is exactly where blocking does fine. And if you have that situation where you have a blocking application with a local database and it works fine, then you're not gonna gain an awful lot of performance when moving to a reactive non-blocking stack. That's important to keep in mind. It might be different at other scales, and it might give you still that stability bonus, but don't expect to change application from blocking to reactive, and then all of a sudden it can do twice as many connections per second. And also it's important to realize that from the database's point of view, nothing changes, right? You just connect to the same endpoint. You say the same things over TCP. So don't expect miracles there. I do like that R2DBC has quite a focused vision. They're really working towards a goal to make R2DBC to make reactive programming complete, because for a while you could do pretty much everything in reactive stacks, except in a convenient way use relational databases like CouchDB or MongoDB have had like a reactive driver for forever, but R2DBC only now. Another thing to take into consideration is that some people really don't like reactive programming, and I'm interested. Maybe we can discuss that a little bit. This is a pretty infamous podcast about RX Must Die. It is a little bit clickbaity because actually the panel discussion is pretty nuanced. It is a good one to listen to, but yeah, and I do understand that if it gets complicated, reactive can be a bit painful, but on the other hand, yeah, everything does. So I'm not too much. I never really suffered that too much, but maybe that's just me. So if you have an interesting position on that, let me know. Furthermore, there are like languages like Kotlin, I just shown, have coroutines. Coroutines, they partially allow you to sidestep reactive programming in the sense that the environment is able to lift the thread out of a method, and when there's a signal, put it back in and continue, like a continuation. It is really popular, and you can do a lot of non-blocking operations without actually needing to go into all the monos, the fluxes, and the flat mapping. It is not a complete replacement. It is not like the whole back pressure, for example, is not something that a coroutine solves. Kotlin, for example, does have something called Kotlin Flow, which offers the rest of reactive programming, and that's actually pretty nice because you do have, it is basically reactive, but without some, wherever they can use coroutines, you can use a coroutine, and it makes it a lot easier on the eyes. And I think the next meetup in 2 weeks will address that. Another pie in the sky is Project Loom. And that's an Oracle project for the JVM, and that promised to solve this problem on a whole different level. They were working on a reactive Oracle driver, well, a reactive standard like Oracle, but also other databases, and they ended up canceling it because they said we just yeah, they're just going to wait until Project Loom makes this unnecessary, because then what Project Loom does is that it can remove the operating system thread from the Java thread. And that means that you can all of a sudden have the same Java code running in your system, but then all of a sudden it's okay with having 10,000 threads. And that is nice, but I'm a little bit worried about it. I'm not going to hold my breath. One of the things with Java is that it's a pretty old language, so there's a lot of weird things in there we might not even realize, and all places where this will act funny. So I am very interested in it, obviously, but I do think that apart from that, it is good to realize the different ways of thinking, because I do think, like, even if you're not going to use it, using reactive does help you think in different ways, and that in itself is valuable. Officially, it's now in some technology preview state, I think, but I have no idea about when it will be generally available. So I'll just address some questions. Maybe I'll do that at the end because I'm nearly done. So conclusion, one thing that I think is important is to realize how many threads we are wasting. We are really used to it, and I have looked at servers with hundreds of threads, and 95% were waiting for something, and that was normal. And I think we should not think it's normal. So in that sense, I think there is, and as I said before, it really looks like a server is busy when it's not busy, and then because we are really so focused on scaling horizontally, we can fix it like that. But I do think that's problematic in the long term. It is part of a Spring framework, but you don't need any framework. I tried with a few other framework, and it's a bit more work than in Spring, but it's all possible. And I think I really applaud Pivotal/VMware for separating that, not forcing people to use Spring, but really try to separate that from the rest of Spring. As I said, it's not necessarily faster. Don't expect that. And this is one of the last pieces of the non-blocking stack. So expect some rough edges. It's not quite mature, but yeah, I'm feeling good. And finally, if you want, I have a demo. It's on GitHub. I just made it today, so you can play with it or not. And for the rest, the only thing I've left is ask for questions. So I'll get into I think Fabio wants to talk.
Yeah. Thanks. First of all, I just wanted to thank you for this amazing presentation. And I liked a lot as well at the end when you gave a bit of an overview of different things, Kotlin coroutines, Project Loom, that you're not holding your breath for it. I really think it was a really cool presentation. So yeah, thanks a lot, Frank. Thanks a lot.
Thanks, Frank.
Yep.
So maybe we can, I see a question about the database. Does the streaming start all the way from the database layer, or the database delivers results as a listed driver, and R2DBC only creates a publisher out of that list?
No, it's all the way. It's all the way. So R2DBC parses the TCP stream, basically. So the data comes in, and it goes straight onto that. And because otherwise you would have that, as I said, you can't wrap something blocking and make it non-blocking. So the only way to do it is really get to the bytes as they come in, and then you need to parse them.
All right. Great answer. You mentioned that Spring does the heavy lifting to balance the producer-consumer balance. I was wondering how easy is it to tweak that process? Do you get any control over that, or?
Yeah, I mean, if you make your own reactive transformers, which you can put in between, then it's up to you to make that work, right? Because you get requests from one side and you get data from the other side. And if you make an operating by yourself, then you need to be aware of that. So yes, you can make an operating to deal with that, and it is actually not that easy, because if you, for example, you have a filter, you can implement a filter pretty easily. So you pass on some of the data and not all of it, but the downstream asks for a certain number. But if you filtered a certain number for more, you need to be aware of that, what you transmit upstream, right? So there is actually, the moment you get into that, reactive programming gets, it's not trivial. On the flip side, you don't need to do that often, in my opinion, but in my experience.
Hey, I have one question. I'm really curious about the thing you mentioned, the podcast Reactive Must Die. And I think as a Reactive Amsterdam, as a Reactive community, we should do an event about that and listen to it. And so what is it about?
A reaction video, yeah.
Yeah. What is it about?
It is not that bad. It is just basically part of the hype cycle. Like there's a lot of, it's mostly focused on Android, and what happened for a while is that whenever you do anything, you press a button, you use RX for that, and it adds a lot of weight to your app, and that's the biggest thing. And yeah, I mean, also the part that if it gets complicated, it gets complicated, and like the usual complaints and your stack trace.
The bugging is difficult.
Yeah, exactly, and your stack trace kind of meaningless things. So, so I mean, we are all, I think every honest reactive programmer will know what they talk about. But yeah, I mean, the alternatives aren't all that great. But it is a good podcast to listen to hear the different positions.
Yeah. I'm out of questions.
Yeah, I see an interesting one, like, does every database support back pressure? And well, yes, because generally all the data gets transported over TCP connection. So that in itself will provide back pressure, because the database will not be able to push it through the line as quickly as it might want. How it deals with it is a different story, right? And it's actually it opens up an interesting thought, in the sense that right now we were really focused on balancing how quickly you get the data from the database with how quickly you can move it on. But in some cases, it might even be better just to sacrifice your memory, just take it as quickly as possible from the database, so the database can get its connection back and do other stuff. And that is really a trade-off. So in that sense, I think they do support back pressure. How much every database likes it is a different question.
We just said, okay.
Yeah.
There's
so
two more. I'll let you.
Let's do the transactions one. Is a nice one. You can do transactions because honestly, in our traditional stacks, we are really used to thinking in transaction in terms of threads. Like you tie it to a thread, but that's not really the truth, right? In the end, a transaction is a message you send to a database, like this transaction starts now, and then you're gonna do things, and then you say complete or rollback or something. So it's just the same deal, only in a reactive way. So there are some good tutorials around it, but again, from the database point of view, it's just somebody on the other end of a connection. So there is no reason that it can't be done. Another one, if you can't consume quickly enough, yeah, at some point, some connection might time out. That is true. So you should not rely on that to be open for hours. And basic OR mapping, yes, that's there. I used a really simple one in my demo. You can look it up. It is, you basically just get a map and you can make something out of it. I don't think there are yet really very there's one Kotlin-based ORM mapping, which is really prides itself on being very type safe. I think it looks nice. I never really touched it, and I forgot the name. It's difficult. Another one. Yes, not handling back pressure correctly happens a lot. I have found bugs in like the Jetty driver, even like the really established ones. If you do something weird, you can break them easily if it hasn't really touched that. So yeah, that is definitely a possibility. So if you are very adventurous in your technology choices, you get hit in the face from time to time. So that's why we live, right?
That makes it fun.
Is that all of them?
I think that's most of them. Yeah.
The last one, if we have to.
There's.
Yeah, I mean, it depends on the database at what clip.
What's the question here?
Sorry, the one of Masood. So
to clarify this?
Yeah, so if the database will just start sending data over the wire, and it will arrive when it will arrive, and so yeah, it will, as the moment it has a clear frame of a document, and that's something that's really implemented in the driver itself. Will have a row, it will pass it on, but you can get into funny situations that you. Especially when there's something wrong or you have an error, it can get a little bit more obscure than normally, because in a blocking situation you have a bit more context in what you're doing. Now they're just bytes, and it tries to parse them, and if there's something wrong, it acts funny. Exactly.
As you said, yeah. That's what happens.
Yeah.
All right, great. I think since there was a little bit of issues with Fabio's slides at the start, maybe we can show this one again for the.
Sorry about that, everybody. I don't know why it happened.
I added a link to the comments to all the slides for people that want to have a look there as well. Yeah.
So in fact, let me add one thing about this conference. So the conference is actually tomorrow, but there is a pre-conference party which is going on right now. It just started. So you're in time to join that.
All right. We have an after party, people. Instead of pizza and beer in real life, another virtual conference to go to. That's labeled a party. All right. Okay. Well, with that out of the way, I would like to thank Frank for an amazing talk.
Thank you.
Fabio for, again, a wonderful collaboration. And thank everybody for joining us, for asking questions. And yeah, make sure to follow the meetup groups for future events. And see you all next time. Thanks.
Have a good one. Thanks, everybody.
All right.